everyone, welcome to Miss Lee's class. Today we're going to learn the concept of a function. So last class we learned what domain is and what range is. Domain is the set of all possible input values, and range is all possible output values. Okay, function. Function is a special type of relation where each element in the domain is associated with exactly one element in the range. Okay, I'm gonna give you an example. So here are some different ways to relate vehicles and the number of wheels each has, which arrow diagram represent a function. Alright, say the input is the number of wheels and 1 is the number of wheels on a unicycle. So you have to connect 1 and unicycle, and 2 bicycle and motorcycle, 3 tricycle, 4 car. If you look at 2 is the input and the input has 2 output. If an input has more than 1 output, then that's not a function. Each input should have exactly 1 output. Look at this. Those are input. This time, bicycle, car, motorcycle, tricycle, unicycle. Those are input. And bicycle has 1 output, which is 2. Motorcycle, 2. Tricycle, 3. Unicycle has 1. So as you see, each input has only 1 output. So here, all you need to do is just count the number of arrows. Each input should have exactly 1 arrow. This one has 2 arrows. Therefore, it's not a function. This is not a function. But if you look at this, each input has exactly 1 arrow. 1, 1, 1, 1, 1. So each input should have exactly 1 arrow. So I want you to write it down. To be a function, right? So which arrow diagram represent the function? This is a function. This is a function because each element in the domain is associated with exactly 1 element in the range. Because each input should have exactly 1 arrow, right? So this is the function and this is not a function. Alright, let's move on. For each relation below, determine whether the relation is a function, justify the answer, identify the domain and range of each relation that is a function. Okay, it's a relation that associates given shape with the number of right triangle in the shape. So those are independent data. So we're going to draw an arrow diagram. So right triangle, acute triangle, square, and rectangle. And right triangle 1, 0, 4. You don't have to repeat the output. You don't have to repeat 0 again. So here, let's draw it. right triangle has 1 right angle, acute triangle has 0, square has 4 right angles, rectangle has 4 right angles. Look at this. Each input has exactly 1 arrow. Therefore, this is a function. Okay? So, justify your answer. Each input has exactly 1 output. 1 arrow, 1 output. It's a function. Next, is this a function? Look at 1. 1 has 2 outputs. 1 has 2 arrows. 4 has 2 arrows. Therefore, this is not a function. So not a function. Because 1 and 4 have 2 outputs. What about C? Okay, everyone, let's look at the graph 0, 0. But if you look at 1, let's look at the input value, which is x value. So 1 has 2 value, which is positive 1 and negative 1. 1.5 has 2 value, here and here. And 2 has 2 value, here and here. So each input has 2 values, 2 outputs. Therefore, it's not a function. Input values have more than 1 output. Therefore, not a function. Okay? Alright. So, we're going to learn a vertical line test for a function. So if you look at this, we figured out this is not a function because each value has more than 1 output. Each input value has more than 1 output. We can figure it out using a vertical line. If you draw a vertical line, if the line passes through the graph more than twice, then that's not a function. Okay? So draw a line. The line should intersect the graph only once. If it is more than once, then that's not a function. So for example, here, you have a graph. This one passes through only once. Once, if you draw a line, once. But if you draw a line here, it passes through the graph 3 times. There are 3 intersections. Therefore, this is not a function. Okay? So here, a relation that is not a function has 2 or more ordered pair with the same first coordinate. So when the ordered pair of the relation are plotted on a grid, a vertical line can be drawn to pass through more than 1 point. So therefore, this is not a function. But look at this. If you draw lines, everywhere the line passes through no more than 1 point. Therefore, this is a function. Not a function. And a function. Okay? And this is called vertical line test. Vertical line test for a function. A graph represents a function when no 2 points on the graph lie on the same vertical line. For example, if you draw a random vertical line on this graph, everywhere the line passes through the graph only once. There's only one intersection. Therefore, this is a function. But look at this graph. If you draw a line, if you draw a random line, here, it goes through only once here, but everywhere else, 2 points. It passes through 2 points, 2 intersections. Therefore, it's not a function. And this one is not a function as well, because draw lines passes through more than once. Therefore, not a function. So you should be able to figure out if it is a function or not using a vertical line test, VLT, for vertical line test. Okay? Okay, circle the graph representing a function. Let's do a vertical line test, VLT. Passes through only once. Everywhere it passes through only once. Therefore, it's a function. So yes, this is a function. Next, is this a function, everyone? Let's do VLT, vertical line test. If you draw a line, if you draw a random line, if you draw vertical lines pass through the graph only once. Therefore, it's a function. Circle. What about this one? Is this a function? Let's draw lines. If you draw vertical lines, they pass through the graph more than once. Therefore, it's not a function. Make sense, everyone? Alright, let's move on. Example 3. So I want you to pause the video and figure out if this is a function, if A is a function or not, and if B is a function or not. Go ahead, everyone. Alright, have you guys tried it? Here, let's do VLT, vertical line test. If you draw a line here, the line passes through the point twice. And here, 3 times. Therefore, it's not a function. Because failed VLT. What about this one? It's a function because everywhere, if you draw lines, the line passes through the point only once. Therefore, it's a function. Past VLT. Alright? Let's move on. Note, we can think of a function as an input and output machine. The input can be any number in the domain, and the output depends on the input number. Okay? So when you plug input value in the machine, output is coming out. So input value, each input, if you put in one input value, then output should be only 1. Each input should have only one output to become a function. Okay? Alright. Example 4. Consider the function with the domain -1, 0, 1, 2. Find the range of the function and show the function as an arrow diagram. Okay. So input, output, okay, -1, 0, 1, 2. And if you plug -1 into this function, so -1, 3 times -1 plus 1. What is this? 3 times -1 is -3, plus 1 is -2. So -3 plus 1 equals -2. So output is -2. If you plug -1 into the machine, output is -2. Okay? So output -2. let's plug 0 into the machine. Then 3 times 0 plus 1. What is this? What's 3 times 0? 0. Plus 1 is 0. So 0, 1. So let's plug 1 into the machine. Then 3 times 1 plus 1. That is 3 times 1 plus 1. That is 4. So therefore, the output is 4. Here, 4. And let's do 2. Let's plug 2 into the machine. Then 3 times 2 plus 1. Then that's 7. 7. All right. Set of ordered pair. -1, -2, 0, 1, 1, 4, and 2, 7. And Cartesian plane. Let's draw it. Okay, -1, -2 is here. And 0, 1 is here. 1, 4 should be here. And 2, 7 over here. So it's a linear pattern, linear relation. Okay, you don't join the points because domain value is only 4 values. The domain has only 4 values, -1, 0, 1, 2. You cannot have more value in between 2 points because we have only 4 domain value, 4 input values. You do not join the point. Alright everyone, that is it for today. Now I want you to start doing your homework. Thanks for watching everyone. Bye.